In today's video, we'll go through the different methods of calculating the number of crossings. So there are basically three methods for this. One is the centerline method, next is right angle method, and the next is isosceles triangle method. So before learning the methods, let's go through the different terms related to this. Theoretical and actual nose of crossing. So we know that in a crossing there are two rails which come and meet. One is the point rail and other is the splice rail. In some cases we'll be having two point rails. Okay. So the point rail is not made to a well-defined sharp point due to the chance of braking under traffic actions. We know that if it is made sharpened, what happens? There is a chance of the wheel of train to come and hit the sharp point on the rail. So it is not made into sharpened one, it is made into a blunt nose. So in actual scenario, a blunt nose is being provided and that nose is known as the actual nose of crossing, which is denoted by the letter ANC. This thickness of blunt nose is equal to the thickness of web of rail, and the thickness of web of rail is varying between 0.6 to 1.9 centimeters. So there is an increasing thickness of web of rail depending upon the increasing gauge value. Now coming to the theoretical or true nose of crossing, the sharp imaginary point, that is the true nose of crossing. We know that in actual scenario it is made blunt, and if it is extended to make a sharpened point, then that is known as the theoretical or true nose of crossing. So I'll show you a photograph which will make you to clearly understand which is the actual nose of crossing and which is the theoretical or true nose of crossing. Okay, so this is the figure. Here you can see that a blunt nose is being made. Okay, if you're extending the rail, then you will get a sharp point, and this point is known as the TNC, that is true or theoretical nose of crossing, and the other one is actual nose of crossing. Now when you're doing the calculations, all the calculations are made from this theoretical nose of crossing and not the actual nose of crossing. Now coming to the number of crossings, it is denoted by the letter N. N is being defined by an expression that is spread at leg of crossing divided by length of crossing TNC. So I have told you that all the calculations is done on the basis of theoretical nose of crossing. Now coming to different methods for calculating the number of crossing. One is the right angle method or Coles method. So this method is usually adopted in Indian railways. Now the centerline method is adopted in foreign countries like USA, UK, etc. And the isosceles triangle method is basically used for the designing of crossings in case of tramway. Now let's go through each methods. First one is the right angle or Coles method. Now you can see that this is the figure which is being adopted for finding out the number of crossings as well as angle of crossing. AB is the point rail and AC is the point or splice rail. If in case you don't remember what is point rail and splice rail, I'll just tell you. This is the point and splice rail joint. That is, one rail will be coming like this and the other will be joined to this. This rail is known as the point rail and this is known as the splice rail. If in case both the rails are of same type, that is this coming and is joined like this, here there is no difference for this and this. So this can be called as the point rail. Okay. So you can see in the photograph also, here you can see one is coming like this and is coming up to this portion. Here also it is coming up to this portion. If in case this is one single rail joined here and the other rail is getting joined to this portion, then it is a point rail and a splice rail. Okay. Now we'll go through the figure. This alpha value is the angle of crossing and AC is known as the number of crossing. Okay. So in actual scenario, what is done is, when you have a figure like this or when you have a crossing like this value is taken as 1 meter. When you have 1 meter like this as in BC, then the corresponding AB value and AC value is taken. The AC value will be the number of crossing value, and then you will be finding out the alpha value by doing the calculation. Now tan alpha from the figure is what? It is opposite by adjacent value, tan alpha, which can be written as 1 by n. Now angle of crossing is given by alpha, and it can be written as what? When you take the reciprocal of tan alpha, it becomes what? Cot alpha. And if you take reciprocal of 1 by n, it becomes n. Okay. So from this expression, what you can say is the number of crossing n is equal to cot alpha. This is adopted in Indian Railways, and what we can say is if the angle of crossing alpha is getting more and more, then the permissible speed becomes lesser and lesser. That is, the speed which is being limited in case of crossing becomes, or it gets reduced. Coming to the centerline method, here what we do is, this is the figure which we adopt. This is not the right angle method. Here, this complete portion is taken as alpha. Okay. AB is a point rail and OC is a point rail again. The entire angle what you have here is taken as alpha. That means if you are drawing a center line, you will be having alpha by 2 and next alpha by 2. I have told you this BC value is taken as what? 1 meter. If a center line is drawn, then this value will be 1 by 2. This value will be 1 by 2. From the figure, if you take tan alpha by 2, what we have is, it is 1 by 2 divided by this value, which is given by n. You know here, n is the number of crossing. So 1 by 2 by n can be written as 1 by 2n. Okay. Now if you are taking the reciprocal, you will be getting what? Cot alpha by 2 is equal to 2n. From this, you can write it as n is equal to 1 by 2 cot alpha by 2. And as I have said you earlier, this is adopted in foreign countries like USA, UK, etc. Now coming to isosceles triangle method. Okay. Here, isosceles triangle is being considered, that is, AB and AC are equal. If in case these two are equal, and when you are having a value of 1 meter here, then if your center line is drawn, this will be half, this will be half. Okay. So this value is taken as n. So in the previous two methods, what we considered was this A is being joined over here, and the value what you are getting, this straight line, that value is taken as the number of crossing. Here the slanted value or the side of the triangle value is taken as n. Okay. So now if you are taking sine alpha by 2, then what you will be getting? Sine alpha by 2 will be equal to what? It is opposite by hypotenuse. We actually want a relationship between n as well as the alpha. So that is the reason why we are taking here sine. Okay. In the previous methods, what we took was tan alpha, because there this was the opposite value and this was the adjacent value. The straight line was the n value. Here n is taken as the side of the triangle. So in order to get this n, we have taken sine alpha by 2 is equal to 1 by 2 by n, which can be written as 1 by 2n. Now if you are taking the reciprocal, what you get is cosec alpha by 2, which is equal to what? 2n. Now n can be written as 1 by 2 cosec alpha by 2. Now this method is important for the layout of triangle. Okay. So since the angle of crossing alpha is very small, the difference in the value of n by different methods also will be very small. So on Indian railway track, the common number of crossings are 1 in 6. I have told you 1 by n is the expression, or that is the way how you represent the crossing. 1 in 6 or 1 in 8.5 and 1 in 12. These three are the common number of crossings. I will repeat: 1 in 6, 1 in 8.5 and 1 in 12. Now further, we are having a value of 1 in 16, and that is recommended as the maximum number of crossing on the broad gauge and meter gauge track. Out of these, at present, the common or the most common is 1 in 8.5 and 1 in 12. Okay. So I have told you 1 in n it is. So n is what? The number of crossing. So you can take the value as n is equal to 8.5 and n is equal to 12. Then one more thing, as I have told you, when the angle of crossing is getting more and more, then the permissible speed as well as permissible speed will get lesser, and this also can be said in a vice versa also. That is, number of crossing, if the angle of crossing is getting increased, the permissible speed decreases, and the permissible speed increase only when the angle of crossing decreases.